Hello everybody and welcome to our paper presentation named the Blockchain-Based Pattern for Confidential and Pseudo-Anonymous Contract Enforcement, written by myself, Nicolas Six, Claudia Negri-Ribalta, Camille Salinesi and Nicolas Herbeau. So first of all, I'm going to present the context of our study and a bit of background. Then I'm going to talk about our solution, which is an on and off-chain smart contract binding for confidential contract enforcement pattern from a structural but also a behavioral point of view. Then I'm going to talk about the conception of a solution based on this pattern. I'm going to talk about a short analysis of our solution and then conclude. So first, let's do a quick recap about what is blockchain. Blockchain can be seen as a distributed database of interconnected blocks accessible only for reading and appending. And one key property of blockchain is that no central third-party authority is in charge. Blocks can contain transactions, but it can also contain smart contracts, which are autonomous programs running on-chain that can store state and execute operation. And what's interesting in smart contract is that they could act as legal contracts. Because if we take an abstract definition of legal contract, a legal contract is a list of rights and duties of involved party, something that could be done using the smart contract function. It has a defined object, something that could be also done using the purpose of the functions, and is validated by involved parties. And we could use contract signatures to do that. So it could also be really advantageous to use smart contract as legal contract because once deployed, they are immutable and it will strictly follow the behavior defined in the code. But problems can arise when using blockchain smart contract as legal contracts. First, the code interpretability, because two lawyers could have a different understanding on the purpose of the code, and so it could lead to conflicts between two parties. Second, the contract mistakes. What if a bug occurs in the code? How do you litigate between parties? Third, the translation of legal concepts into code that could be impossible or really difficult to do. And fourth, the acceptance recognition, because smart contract could not be recognized by litigation courts, for example. And it also poses several risks concerning data, because in the blockchain, everybody can see the data depending on the blockchain, and also as contracts are immutable, data and logic cannot be removed from blockchain after addition, so it could lead to breach of data privacy or data confidentiality. To bypass those issues, some studies have tried to facilitate the usage of smart contracts as legal contracts. So for example, let's mention the Ricardian contract that are contracts readable by humans and computers thanks to tags that encapsulate some important words inside the legal contracts, and so it allows computers to extract the value inside the contracts. And also a Ricardian contract is digitally signed, and signed contract has its store on-chain. So you can't alter the contract after signatures because you can just retrieve the hash which is stored on-chain and compare it with the contract to check its authenticity. But unfortunately, no traceability of contract clause execution and event at runtime is possible. In another study, authors propose a pattern collection for blockchain-based application that includes one that binds a blockchain smart contract with a legal contract. But unfortunately, this approach does not address the confidentiality of data on-chain and is also very high level. And another approach could be using business processes to mirror the logic and the life cycle of a legal contract. So for example, for blockchain, the study executing collaborative decision confidentially on blockchain, propose the execution of business processes off-chain, and store proofs of execution, so for example inputs and outputs, and this is mostly for decision making on-chain. And in case of conflicts, the logic of a business decision is revealed, and so parties are rewarded if they acted accordingly to the contract or punished if they try to cheat. But unfortunately, this approach has no clear binding to legal contracts, so we want to go one step further by proposing a blockchain pattern named an on and off-chain smart contract binding for confidential contract enforcement pattern. And this pattern enables the enforcement of legal contracts by keeping logic and business information off-chain while storing state on-chain. And this pattern has three main forces. First, the participant pseudonymity, because every organization that wants to use these patterns to run a legal contract with other organizations can remain anonymous on-chain, using a clear binding between a pseudo-identity on-chain and their real identity off-chain embedded in the legal contract. Also, it allows the traceability of every event that occurred during the execution of the legal contract. So, for example, the enforcement of clause, exceptional clauses that were raised between this life cycle, and other events. And third, as only states are on-chain, we are sure that the data remain confidential. So now let's deep dive into the solution from a structural point of view. First, we have the smart legal contract, which is a legal contract, so a contract text written by lawyers that are augmented with tags, a bit like a Ricardian contract. And so you can perform operation on this legal contract using function and logic. So we have this layer of data and logic that are encapsulating the legal contract. And it allows the enforcement of clause through functions. And each participant have a copy of it. So each participant can locally enforce clause and just share to the other participants that they have enforced the clause, and they can store the proof on-chain. And so here, a legal contract is constituted with participant information. So for example, the name of the company, the contact, the physical address, and the most important, the blockchain public address to establish the clear binding between the on-chain address of the company and the off-chain address. We also have the contract clauses written as text, the smart contract address to legally define which smart contract is binded to this contract text. And so we have the remaining contract text encapsulated with tags for retrieval of information. So in the second time, we have the business process execution engine, which executes an instance of BPMN, which stands for Business Process Modeling Notation, that modelizes the contract flow of clause enforcement. And it also makes the bridge between the blockchain smart contract and the smart legal contract, as both are called by the business process execution engine if needed. So for example, if you want to enforce a clause, store a proof on-chain, or call another system. And as the third part, we have the blockchain smart contract. So the blockchain smart contract is binding to the smart legal contract. It is common for every participant of a contract instance. So as well as you have an instance of legal contract signed by many participants, you have a binding blockchain smart contract. It stores legal contract states, so for example, signature, clause, decisions, and so on. It can also store participant information, so mostly they are a pseudo identifier on-chain, And also it stores the logic that does not break any data confidentiality. So for example, you can change the state of a clause without leaking the clause itself using a request from off-chain. So now let's move on to the list of participants that could interact with this kind of pattern. So first you have the organization. They are actively involved in the contract, having rights and duties for example, fulfilling clause and interacting with other organizations. Then you have mediators that could interact if there is a problem in any kind of clause. They can enforce manually clause or try to litigate between two or more parties. And in the first place, you have oracles that are off-chain trust third party, and they are in charge of bringing data for enforcement into the blockchain because the blockchain cannot actively collect the data. The data must be imported from the outside. And each organization and eventually the mediator own a copy of the smart legal contract off-chain, and they synchronize themselves through the blockchain smart contract states and also exchanges direct messages. For example, they can alert other parties on events that happened on their side. This is just an example. So now, on a behavioral point of view, we have a few states that the smart contract can take. So the first one is awaiting signature. So the contract is not considered in execution until it has collected all the signatures from every participant. So the participants can sign the contract using their way of authenticating on-chain. The most common way is using their private key to generate a signature. The contract can also be cancelled. So for example, if there is an error in the code after the deployment of the contract on-chain. After that, the contract goes into an execution state, where you can pass into three different states. The first one, the regular one, is completed. It occurs when every clause has been enforced, so every required clause has been enforced. The second one is terminated. It's like the error of state of the contract. So, for example, if an exceptional clause occurs or an exception was raised by a participant. And the third state possible is litigation, and it occurs when two or more participants, two or more organizations are in conflict. And in this case, the contract is locked into this state, and a mediator must do something to litigate between the participants. So it can terminate the contract, it can force the completion, or it can just put back the contract in execution and enforce manually some clause. And to go more in depth through the behavioral standpoint, four notable points about the behavior of this pattern can be noted. So the first one is signature. So participants agree on the smart legal contract content, sign it, and send their signature to a participant responsible of deploying the blockchain smart contract on-chain. After that, we have a phase of contract execution. So participants will locally execute the steps of their business processes and wait for activities that require signature and/or enforcement of clause. So most of the logic and action are performed off-state, and only when two or more organizations need to acknowledge on something or other activities that requires collaboration, they are going to interact with the blockchain smart contract. A third point is that at any moment, a participant can monitor the contract by retrieving the blockchain smart contract states and operations performed to compare it with its own copy of the smart legal contract. And so you can get a complete contract enforcement traceability. And fourth, we have the contract litigation. So for example, when two participants are in conflict, we have an entitled mediator that can litigate the contract by manually enforcing clause, signatures, and as we saw, he can also put the contract into termination. And to validate our approach, we designed a solution that is able to fulfill the goal of this pattern. So we based the smart legal contract on the Accord project smart legal contract model, constituted with a logic part, a model part, and a natural language part. So the Accord project is an open source project for developing a smart legal contract ecosystem, and we aim to use it later into our implementation of this solution. And as we saw on the previous slide, we have 4 main behavioral points that are going to be supporting the solution through well-defined choreographies and their corresponding implementation. And this solution is tailored to function with any public blockchain, but we chose to perform its future implementation using Ethereum mainnet. And as this is a work in progress, we don't have an implementation yet, but we have a rationale about how this pattern is supporting the requirements mentioned at the beginning of this presentation. So first, the pattern guarantees the pseudonymity of the participant or their business information. So how do we do that? We have a binding between public key and organization that is kept off-chain. We have also a public and a private key pair, unique for a business process instance. So if a company uses this solution to perform operation on 2 smart legal contracts at the same time, they will have 2 different sets of public and private key. And the third aspect is that state can be obfuscated. For the second requirement, the pattern ensures that an immutable audit trail can be retrieved. To support that, every sent message and perform action are logged off-chain by each organization. And so, an organization can easily infer this information with the blockchain smart contract to get the traceability chain, as well as they keep the information off-chain. And as a third requirement, we argue that proof stored on-chain following this pattern could aid or work as evidence in dispute resolution, as when signing the contract, participant agrees on blockchain smart contract authority to trace action. And also, as the blockchain smart contract is immutable, it's reliable if the logic is correct. But this pattern is not a fit-all solution and it could be subject to threat of validity. So for example, we could have malicious actors that are compromise oracle or malicious organization trying to tamper with the good execution of the smart legal contract. We could also have losing off-chain information. So what happens if every organization in the contract loses its access to their off-chain information? How are they going to retrieve the information using the blockchain smart contract? It's impossible. And third, a more technical issue is the blockchain scrapping with logic. So knowing the initial bytecode of the blockchain smart contract, it could be possible to retrieve all of them and then infer that state with another version of the smart legal contract to extract information about ongoing business processes, for example. So as a conclusion, this work aims to propose a pattern to leverage smart legal contract on-chain. And the main point of that is that there is no text ambiguity. We have an ensured confidentiality and a pseudo-anonymity of organization. The auditability of the contract process is possible, and it can be applied in many contexts involving contracts. And we aim our solution to contribute to the state-of-the-art of blockchain patterns. But however, some work remains to be done, as we didn't have an implementation yet. So we plan to implement this solution to formally prove that the pattern fulfills its requirements and also demonstrates that its implementation is feasible. And following the implementation, we would like to test and validate this pattern in a real-life use case through this implementation. Thank you for your attention.